Welcome back, Ganzami. Now let's look at what we call exponential graph. Okay, this one is in the form of y equal to ab exponent x, or it can be in the form of y equal to ab exponent x plus q. But what is q? Q is what we call asymptote. Okay, which means our asymptote is equal to y. It's y equal to q. If I can make an example here to say I have 2 exponent x plus 2. This will say our asymptote obviously here is what? Is 2. So basically that is what you must take note of. Okay, but now what about this shape? What about the A? What about B? Okay, let's stop there for now. Let's forget about that. Let's look at one example, then we conclude after that. Okay. Let's say now you have something like this. This is our G equal to 2 exponent x. Okay, here you have only one term, and if you have only one term, you simply use your table method. Okay, here you can put -1, 0 and 1. If you put -1 there, here, this will give you half. This will be 0.5. Obviously, if you put 0, any number raised to power 0 is 1. Okay, and this one, if you put 1 here, this will give you 2. Right? Then, now we are required to sketch this one. Okay. We start with our asymptote. Obviously, since you don't have anything here, which means our asymptote is 0. So if we are required to sketch this one, I have 1 and 2. So this can be 1, this is 2. This is -1, this is -2. Obviously, this is 1, this is 2. -1, -2. And we know this is our y-axis, this is our x-axis. Okay, for -1, this will give you half. Here we go. But then, if now you have 0, this will give you 1. If you have 1 as x, then your y will be 2. So it's something like this, which means your graph will be something like this. Wow. So this means this graph is increasing. This is what we call an increasing function. Why we are saying this one is increasing? As you can see here, as x increases, and your y is also increasing. So this is increasing because both x and y increases. Okay, this is very important. Now look at this one. This is your b. Now your b is greater than 1. Right? Your b is greater than 1, since your value of b here is what? Is 2, whereas the value of a is 1. So if the value of b is greater than 1, that will give you what we call an increasing function. That is what is important. But again, if you can see this one, they are teaching us maths. Using the right hand rule, if you say I sugar, this will give you the shape whereby your b obviously is greater than 1. Now let's look at the other example whereby b now is between 0 and 1. Okay, this is another example. This is f now equal to 2 minus x. Here we say our b is between 0 and what? And 1. Why saying that? Because if you change this one, This is same as 2 negative 1 exponent x, which is 1 over 2 exponent x. And you can see you have half, which means your b is 1 over 2. So that is the value which is between 0 and 1. And if it is like that, it means that our function will obviously decrease. Why this one will decrease? What we have to see there is our x values increases. To see our x values increasing, but our y, so we would want that they are decreasing. Okay, let's check. The first thing to use, obviously, it's a table. Let me put it here. Then we set for the table. Let's simply put negative 1, 0, and 1. If you put negative, you have negative here. This will give you positive. So 2 to the power of 1, that is 2. You put 0 and number raised to power 0, it's 1. If you put 1 there, that will give you 0, 5. Now let's sketch the graph. This is just our rough sketch. This is our y. This is our x. We have 1, obviously negative 1. We have 1 and 2. Let's check. When your x is negative 1, obviously your y is positive 2. So it's something like this. Here is a point. If your x is 0, your y is 1. There we go. If your x is 1, your y is half. There we go. So it will be something like this. And as you can see that as x increases, your y is decreasing. So that's why we said this one is a decreasing function. Because as x increases, your y is decreasing. So we call it a decreasing function. So that is what is important with this one. Obviously, we have to indicate one coordinate here. This is negative 1 and 2. But this one is obvious as 0 and 1. Now let's look at the last example based on the exponential graph. Okay, whereby you have to look at what we call x-intercept. Here we have g of x. Let's say this is 2 exponent x. Let's say this is minus 8. Now we have q, right? Which means for this one, the first thing that we have to indicate is our asymptote. We know our asymptote is equal to minus 8. Since we have two terms, these 2 exponent x is minus 8, which means in this case we have to look at what we call x-intercept, obviously by letting what? Y be 0. So we put 0 here. This would be 0 equal to 2 exponent x minus 8. You take 8 to this side, it would be positive 8 equal to 2 to the power of x. You change 8 would be 2 to the power of 3. Those are the exponents. But we say if bases are the same, you equate the exponents, which means your x here will be 3, right? Then in a coordinate form, this will be 3 and 0. Okay, we use this base for the y-intercept. For the y-intercept, what do? You let x be 0. So this will be y equal to 2 exponent 0, because where there is x, you now put 0, minus 8. And this will give you 1, because we say any number raised to power 0, it's 1 minus 8. And obviously this will give you negative 7, which means our coordinate here will be 0 and negative 7. Then we're done. We have our asymptote. We have our x-intercept. We have the coordinate for the y-intercept. Then we can now sketch the graph. Sketching the graph, you start with your asymptote. What is our asymptote here? It's negative 8. So let's extend this line, because we have negative 8 now. So let's say this is negative 2, negative 4, negative 6. This is negative 8, and this one should go like that. So this should be 2, 4, 6, obviously you have 8 up there. And along the x-axis you have 3, so this can go like this: 1, 2, obviously is 3, and this is -1, -2, this is -3. So if you are sketching this one, you start with your y-intercept, which is -8. So this is your asymptotes, not the y-intercept, but it's your asymptotes. Or this one should be a dotted line. That's the starting point. But you can see here your b is greater than 1, so that's the increasing function. It should be something like that. You say I sugar, you use your right hand and you say I sugar, that will give you the shape. Now let's check whether our shape will be like this. This one, it will cut along the y-axis, whereby your y is -7, so it's something around here. But our x is 3, or it's something like this. Oh wow, so this is our function. And obviously this is increasing, so which means our function is correct. So that is what we have to know. So that is all about what we call exponential graph, and we now left with hyperbola graph. Okay.